The Big Bang idea doesn't make as much sense now that the James Webb Space Telescope has found new information. The James Webb Space Telescope just made an amazing finding that is shaking the field of physics worldwide with one stunning picture. It ended long-running arguments which have left experts speechless. No more guessing, the Webb Space Telescope's most recent discovery is both stunning to look at and a game-changer that could change the way we see the world. What heated argument among experts has this picture finally put an end to? How does the beautiful picture taken by the James Webb Space Telescope change the way we think about the universe? Come see why it's getting buzz as we look at the image that ends the physics argument that James Webb found. One of the main problems in astrophysics is that scientists can't agree on how old the universe is or how fast it is growing. Scientists of all generations have been puzzled by this unsolved phenomenon, and they are doing a lot of different studies to find answers. Scientists who study cosmology try to figure out how the world was made, how it works, how it has changed over time, and how it will end. In the last 100 years, there has been a lot of progress in this area. The Big Bang theory, which is the most popular theory in cosmology right now, says that the universe has been growing for about 13.8 billion years, starting out very hot and dense. The Hubble constant, which shows how fast the universe is growing, is used to measure this growth, but it's not easy to figure out how to measure the Hubble constant. There are two main types of measurements for the Hubble constant: local measurements and measurements from the early universe. Local measurements look at things in space like Cepheid variable stars and type Ia supernovae, which are used as standard candles to measure the Hubble constant. Because of how bright they are, astronomers can figure out how far away these objects are by measuring how the expansion of the universe changes their speeds. This lets them figure out the Hubble constant. There are two groups. The second group is measurements of the early universe. Scientists use readings of the cosmic microwave background radiation, CMB, which was found in the 1960s to be the glow left over from the Big Bang. The microwave energy from the early universe, when the universe was only 380,000 years old, was seen by the CMB. Astronomers can figure out how old the universe is and how fast it is expanding by measuring the tiny temperature and polarization ripples that the CMB sends out. However, there is a problem. These two methods do not give the same results. The findings from local measurements back up our guess that the universe is expanding faster than the CMB data suggests. Scientists have been working hard to figure out why the results are different. Because of these differences, more study is being done in order to find out more about the mysteries of the universe. The different measurements show that either we don't know about any new science yet, or there are mistakes in one or both of the ways we are measuring things. We can see farther into the darkness of space than ever before, thanks to the James Webb Space Telescope. Because of what it can do, the telescope can show us elements, planets, and galaxies that we would not have thought were possible to see. Scientists naturally thought that information from the Webb would help them figure out the Hubble constant more accurately. The first wave of data, on the other hand, has made things a lot more difficult. They've taught us new things that don't fit with what we thought we knew. Could this information help us come up with a new idea about space that changes the way we think about it? If so, we might need to rethink what we know about how the universe works. For example, we might find particles and forces that have never been seen before. Or it could mean that dark energy, the unknown force that is speeding up the growth of our universe, needs to be looked at again. As we keep finding new things, our ideas about space have changed over time. One example is the cosmic microwave background radiation that scientists found in 1965. It was strong proof of the Big Bang theory. Before that, scientists thought the universe would last forever, which meant it would keep growing at the same rate. However, the new proof showed that wasn't true. Also, when we learned near the end of the 1990s that the universe was growing all the time, we learned about dark energy and how it affected the expansion. So whenever we learn something new, we check to see if it fits with what we already know. We come up with new ways to understand the universe better. If not because of this, the problem we're having in cosmology right now could lead to the finding of the best ways to fix the universe. Although the problem is difficult, it is also exciting because it pushes us to make better tools for exploring space. Scientists from all over the world are interested in this cosmological problem because they all want to know more about the universe. The most important thing is that it shows how science is always growing and changing as we learn more about space. The S8 tension is another worry that goes along with the Hubble tension. This is about how matter is spread out in space. In the world, you can use this to make a structure of the world and see how it has changed over time. This is called lumpiness by scientists because some parts of space have a lot of galaxies close together and other parts don't have many. Different methods will be used by the scientists to find out how big this lumpiness is. A possible answer is to look at how the different densities of big things like galaxy groups bend light from galaxies far away. Gravitational lensing is the name for this bending. It lets us look into where dark matter is since it doesn't give off light and is therefore undetectable. Scientists also use the cosmic microwave background, CMB, which is a glow left over from the Big Bang. This light has been moving for about 13.8 billion years, carrying messages from the beginning of the world. Scientists can figure out how the universe was lumpy when it was first created by analyzing the CMB. This should match how the universe is observed to be lumpy right now on a large scale. But there's a catch. These numbers don't match up either. The lumpiness of the CMB, which is shown by the non-spherical gravity distribution model, suggests that the early universe's matter distribution was more even than what was seen with gravitational lensing. We can guess that there is something else we are not taking into account in the interpretation. This takes us back to the idea of dark matter. What does dark matter really mean and how does it work? The question still hasn't been answered, but there is still hope. The James Webb Space Telescope will change the field of astronomy with its camera sensitivity and clarity that have never been seen before. The telescope will look into the early times of the universe and find out how the first galaxies and stars came to be. This lets us get better measures of how the universe is expanding and how matter is spread out. In order to answer these important questions, we will need to carefully observe things and maybe come up with new theoretical methods. Finding out more about dark energy, learning completely new physics, or even just getting a better idea of how dark matter behaves will have huge effects on many areas of life. Trying to figure out the mysteries of the world is like putting together a zillion-piece puzzle while wearing blindfolds. Scientists are like thorough detectives who are concerned with figuring out what's going on. Project Flamingo, NASA's newest effort, shows that the agency is becoming more and more interested in scientific exploration. Project Flamingo is a huge step forward in computer science. It uses one of the most famous supercomputers in the world, which is located at Durham University in Britain. It takes more than 50 million computer hours to make and has 30,000 processors and more. The activity shows that scientists are determined to study the whole universe with a main focus on dark matter, the strange substance that doesn't give off, absorb, or reflect light but is thought to exist because it pulls visible matter together. Scientists are still puzzled by how hard to find it is. Project Flamingo, on the other hand, takes a different method than other simulations. It includes all kinds of cosmic things from stars and black holes at the center of the universe to galaxies with very different amounts of gas. From a simple sketch of a landmass, the representation of the world changed over time using a method that was organized in this way. The goal of big projects like Project Flamingo is clear: to figure out why data that don't seem to match up with the structure of the universe are causing cosmic conflicts. Differences in measurements like these show that we don't fully understand how the world works right now. If you want to compare these metrics to types of music, jazz and classical are like these metrics. Each has its own style but is still linked. Flamingo tries to bring these different points of view together and help us all understand the universe better. But even though it was complicated, the cosmic strain stayed. This conflict still exists as humbling proof that we haven't figured out a lot of the mysteries in the world. It looks like the world doesn't want to share its secrets with us right now. We get a bigger and bigger set of problems to solve as we add more data points and modeling models to our toolbox like Flamingo. Every time you find an answer, it brings up new questions, which makes the search never-ending. It shows that our quest to figure out the mysteries of the world is complicated and always changing. In the early 1900s, Edwin Hubble made the amazing finding that the universe is expanding. Since then, our understanding has grown at an amazing rate. The Big Bang Theory, dark matter, and dark energy are just a few of the new ideas we've come up with to understand these concepts better. Even though we know a lot, we still have a lot to learn about the universe. Even the smartest scientists are stumped by these puzzles. Every new finding, whether it came from the CMB or the gravitational lens, adds a new level of mystery. What makes the James Webb Space Telescope and the new picture it took so exciting? This mission is important because it gives us a chance to answer questions about the universe that have been bothering scientists for a long time. Scientists look at this as a once-in-a-lifetime chance because it could change the way we see the universe forever. In the end, it's not about answering questions but asking the right ones that could change the way we see the universe forever. Through these new findings, we might find answers to problems that have been bothering scientists for a long time. The universe keeps its secrets very close, but as we keep learning more and more, we will get closer to finding out what these secrets are. So when we look at the picture taken by the James Webb Space Telescope, let's not just see it as a pretty sight but as a hint of the huge number of puzzles still to be solved. As we move forward in our understanding of the universe, we can be sure that each new discovery will bring us closer to the best answers and, in turn, will inspire us to keep learning more about the world we live in. The James Webb Space Telescope represents a monumental leap in our ability to explore the cosmos. Equipped with state-of-the-art technology, it promises to unveil unprecedented insights into the early universe and phenomena like dark matter and dark energy. Its advanced capabilities in observing elements, planets, and galaxies will redefine our understanding of the cosmos. One of the most intriguing aspects of the Webb telescope is its potential to resolve long-standing cosmic mysteries. For instance, it aims to refine measurements of the Hubble constant, crucial for determining the rate of expansion of the universe. By studying the cosmic microwave background radiation, CMB, and employing advanced gravitational lensing techniques, scientists hope to reconcile discrepancies in existing measurements and uncover new facets of cosmic evolution. Project Flamingo, another ambitious endeavor, underscores NASA's commitment to pushing the boundaries of scientific exploration. Utilizing cutting-edge supercomputing technology, it seeks to simulate complex cosmic phenomena with unprecedented fidelity. This initiative is pivotal in unraveling the complexities of dark matter and understanding its role in shaping the universe's structure. The quest to understand these fundamental aspects of the universe is akin to assembling a vast cosmic puzzle. Each new observation and theoretical breakthrough brings us closer to comprehending the intricate workings of our universe. As we delve deeper into these mysteries, we not only expand our scientific knowledge but also deepen our appreciation for the wonders of the cosmos. In summary, the James Webb Space Telescope and Project Flamingo represent pivotal advancements in astronomy and cosmology. They offer unparalleled opportunities to explore the universe's origins, structure, and evolution, promising to transform our understanding of the cosmos and our place within it. These endeavors exemplify humanity's relentless pursuit of knowledge and our enduring fascination with the mysteries of the universe.